Section 8.1 is called Similarity in Right Triangles. So we talked all Chapter 7 about similarity. This chapter gets even more specific about right triangles. And if you remember from last semester, right triangles have some special properties, and right triangles have special ratios of their sides. So the first thing we're going to talk about is the geometric mean. You may have heard in algebra about the algebraic mean, basically where you take all the numbers that they give you, you add them up, and then you divide by the amount of numbers that they gave you. So if they give you 2 numbers, you add them up and divide by 2. If they give you 5 numbers, you add them up and you divide by 5. Or if they give you 20 numbers, you add them up and you divide by 20. But in geometry, we have something different. It's called the geometric mean. And instead of adding them all up and dividing by how many they give us, we're going to find the positive square root of the product. Positive square root of the product. So product indicates what operation? Multiplication, right? So we're going to take 2 numbers, such as A and B, and we're going to multiply them. So I put a little dot to show that we're going to multiply 2 numbers together. And then we're going to take the square root. So in order to indicate square root, we're going to say x squared. So once we multiply the numbers, then we're going to take the inverse operation of squaring, which is square rooting. Okay, so let's try it. Example number 1, we're going to find the geometric mean of 2 numbers, 4 and 25. The good news is that with the geometric mean, it's always just 2 numbers, whereas the algebraic mean, it could be 100 numbers, right? And that would take you a long time to add them all together, okay? But with the geometric mean, they're always just going to give you 2 numbers, and you simply plug those 2 numbers in for A and plug them in for B. So in this case, you're going to have x squared equals, and then the 2 numbers, 4 and 25, put a dot between them to indicate multiplication. Get your calculator out, but most of you can do this one in your head, right? What is 4 times 25? 100. And we like 100 because when we do the inverse operation of squaring, which is square rooting, it's a perfect square, right? What is the square root of 100? 10. Okay, so if it's a perfect square, your answer comes out nice and pretty, right? How about when it's not a perfect square, like example number 2? We're going to find the geometric mean, this time of 5 and 30. Same directions, I'm just not going to make you write them. We're going to find the geometric mean of 5 and 30. So we're simply going to plug them in for A and B. That's going to get us x squared is equal to 5 times 30. Again, you're going to get your calculator out and multiply those 2 together. But most of you can multiply 5 times 3 and then just add a 0, right? So that should get you 150. And then there's 2 ways you're going to be asked to give the answer. Either they're going to tell you to give it as a decimal. So let's say they say 3 places. Or they might tell you to write your answer in what we call simplest radical form. Okay, so depending on the directions is going to depend on how you write your answer. So if they ask you for your answer as a decimal to 3 places, you're simply going to take your calculator and you're going to type in, on this calculator, you're going to hit the second button, and then the one above the x squared is square root. Type in 150, and then hit the equal sign, and then you're going to round to 3 3 places. So in front of the decimal, you have 12. You don't do anything with that. And then after the decimal, you have 247, 44, 871. So that's either going to stay a 7 or it's going to round up to an 8. And how do you know? You look to the number right next to it. The number right next to it is a 4. So is it going to stay a 7 or become an 8? Stay a 7. So it should be 12.247. All right? That's how you do it on your calculator. If they ask for it to a certain number of decimals, they might say 3, 2, 4, whatever it is. Okay? So it's either going to stay or round up. The other choice is to write it in simplest radical form. So what you're going to do is you're going to take the 150 and you're going to get what's called the prime factorization. What's the smallest prime number that goes into 150? Well, it's even, right? Because it ends in a 0. So what's the smallest prime number that goes into it? 2. 2 goes into it 75 times. Does 2 go into 75? No. But something else does. What's the next prime number? 5 will go in there, but 3 is smaller, so let's put 3 in there. 3 goes into 75 how many times? 3 times what is 75? You have 75 cents in your pocket. You have you have 3 coins. What are they? Quarters. They're 25 cents, right? Now we get to our smallest prime number being a 5 and a 5, right? Okay. So that's the prime factorization of 150. Any pairs that you have will come out. So we have a pair of 5s. That means that number comes out in front of the radical. And then the 2 and the 3 do not have pairs. So they stay under the radical, and we multiply them together. What's 2 times 3? 6. Okay? So your answer is either 12.247 or your answer is 5 rad 6. You're just going to need to read the directions. Okay? If it doesn't tell you one way or the other, pick which one you like better. Okay? If it doesn't say, give it to me as a simplified radical, then pick which one you like. Okay? All right. Now let's talk about the geometric mean in a triangle. All right, so this is the reason we learned about geometric mean, is because it's going to be applied to this right triangle. All right, so we're going to start by drawing a right triangle. And we're going to label this triangle, this vertex over here is A, B, C, and it's definitely a right triangle, right? It's got that little box in it, okay? And in this triangle, we're going to draw what's called an altitude. So from that right angle to the hypotenuse, we're going to draw in this line called the altitude. Talked a little bit about it last semester. It's a special segment. It also creates 2 more right angles, which means that you end up with 3 triangles that are all similar. Okay? They're all right triangles. They're just turned and different sizes. Right? This one over here is the smallest. This one's kind of going to be medium. And then the whole thing is obviously the biggest. Right? So within this one big triangle, once we draw in the altitude, we get 2 more similar triangles. So we end up having 3 similar triangles. So triangle ABC is similar to triangle ACD, which is also similar to triangle CBD. Okay? Oh, we didn't write in the D. This is D. There's our point D. So you're going to notice that they're turned from each other depending on where the right angle's out. So when you go to write it, make sure that your order is perfect, right? Because order matters. All right. So let's look and see what you're going to do with this geometric mean thing. So example number 3. We're going to draw a triangle. And we're going to fill in some values. Oh, I need to draw in the altitude right here. We're going to draw in or write in some values. So we'll call from this point right here to this point right here is 9 inches. And the altitude right here is 6 inches. This little piece from here to here we'll call X. This side over here we'll call Y. And this side over here we'll call Z. So, yes. Wrong way. All right, so we're going to do the altitude corollary first. All right, so in this case, we're going to say that h squared is equal to x times y, where the h squared, underneath it write ALT, which stands for altitude. Let me make it bigger. Move it up. Is the altitude squared is going to be equal to the 2 pieces on the hypotenuse. We'll call it hypotenuse 1 and hypotenuse 2. Because see right here, it breaks it into this small piece and it breaks it into this small piece. Okay? So the altitude is labeled 6 inches. So we're going to say 6 squared is equal to one of the pieces of the hypotenuse times the other piece of the hypotenuse. So one of them is 9 and one of them is x. If I'm multiplying them, does it matter what order I put them in? Not necessarily. No. I could write 9 times x, or I could write x times 9. Okay? As long as you get one of each. Okay? Then we're going to simplify. So 6 squared is what? 36. And 9 times x is just 9x. We divide both sides by 9. I'm up here with my answer. So x is equal to what? How about 4? 36 divided by 9. If you can't do that in your head, you definitely need a calculator on you. All right? I need to move this up because I'm running out of paper. So you'll see it in just a second. Okay, so we've got the x. Now we need to get the y, right? Because we've got a y side over here and a z side over here. So that corollary says that this side, y squared, is going to be equal to the piece that's closest to it times the length of the whole thing. Well, guess what? We just figured out what x is, right? It's 4. So that's the piece that's closest to it times the length of the whole thing. What's the length of this whole hypotenuse? 13 inches. Once you calculate both of those, you can add them together and get the length of the whole thing. So 4 times 13, punch that in your calculator, you're going to get y squared is equal to 52.